Hello. In this video, we want to talk about exponential equations. What are exponential equations? These are equations that are derived from indices and logarithms, because basically they are equations that require the techniques of logarithm and indices for them to be solved. Okay, so in this video, we shall be looking at examples of how such equations could be solved. So let's start with example 1. Let's start with example 1. Example 1. If 25 raised to the power of x is equal to x raised to the power 10, find the value of x. Okay, now I want to find the value of x here. So let's look at how this could be solved. You can see that this is an exponential equation. You can see the exponent x here. You can see the exponent 10 here. So let's start. Now our target here is to reduce this 25 raised to the power x to an integer. So let's say that for us to reduce 25 raised to the power x to an integer, we have to find the 1 over x of this exponential 25 raised to the power x. So we have 25 raised to the power x into 1 over x. Okay, so will be equal to x raised to the power 10 into 1 over x. Yes. All right. So recall, according to the law of indices, we have x raised to the power a bracket of b. It's the same thing as what? X raised to the power b bracket of a. If b is swapped with a, it will be like this, which is the same thing as what? X raised to the power a b. Okay, that is a law from indices. So in this case now, that means we are going to multiply this x by 1 over x. So we have what? 25 raised to the power x times 1 over x is equal to what? X raised to the power. We could bring this 1 over x here and write 10 here. It's still the same thing. So 1 over x, like I showed in the theory of indices, the raised to the power 10. So by the time I, cancel this and this, that is x over 1 times 1 over x will cancel x. So what? 25 raised to the power 1 is equal to what? X raised to the power 1 over x multiplied by raised to the power 10. Now, with this, we can actually remove this exponential 10. And how do we go about that? To remove this exponential 10, we could find the 1/10 of this particular equations. That is, let's say 25, this is 1, raised to the power 1 times raised to the power 1 over 10, okay, is equal to x raised to the power 1 over x times 10 multiplied by the power 1 over 10. Okay, so with this, we could have, now let's write it there. This is what? 25 raised to the power 1 over 10. That will become, because 1 times 1 over 10 is that. Okay, then it's equal to, this will cancel this. You have what? X raised to the power 1 over x. I hope we are following. All right. So with this now, we could reduce this to the index form by saying that this will become what? 5 raised to the power 2. Yes, that raised to the power 2 is representing what? Representing 25. Then raised to the power of 1 over 10, okay, is equal to what? X raised to the power 1 over x. Beautiful. So with this now, we could say that by the time we multiply out these 2 by 1 over 10, you have what? 5 raised to the power. This will come to have 1 over 5 is equal to what? X raised to the power 1 over x. Now, comparing this left-hand side and this right-hand side, you observe that compare the integer here with the integer here, x will be equal to 5. And here you have comparing the exponent, 1 over 5 and 1 over x. They are saying that 1 over 5 is equals to 1 over x. If you cross multiply, x will be equals to 5. So that means when you compare the exponents, you get 5. When you compare the integer, you get 5. So in that case, x is equal to 5. So it's as simple as this. So the answer to this equation is x is equals to what? X equals to 5. So you want to verify. When you put 5 here, 25 raised to power 5 will be equals to the same thing as 5 raised to power 10. You check that. You can check that with your calculator. So that is equation example 1. Let's look at example 2. Hi, I'm Dr. OJ. So don't hesitate to what? Click the notification bell so that each time I upload this kind of amazing tutorial videos, you'll be duly informed. Now let's look at example 2. Another example here, example 2. Now this one says solve for x in the equation. Solve for x in the equation. Okay. Now the equation is what? 2 raised to power x is equal to x raised to power 4. Alright. Now, this is another exponential equations. So, let's want to reduce this just like with the way we went for the first one. Now we could trade that path too. So we can say what? Say solution. So to reduce this 2 raised to power x to just an integer, you have what? Let's say we take 2 raised to power x, take 1 over x of the exponent of x. Okay? We say that what? X raised to power 4 multiplied by what? The exponent of that is, you take the 1 over x of both sides. Okay? So by the time you do this, what you have? You have what? Multiplying this x by 1 over x. You have what? 2 raised to power 1 is equal to what? So you can bring this one in and take them out. It's no problem. So you can say what? X raised to power 1 over x multiplied by 4. Beautiful. Now, you observe closely that this has exponential 4, this has exponential 1. So now to neutralize this 4, we can take 1/4 exponent of this. That is, we say what? 2 raised to power 1 of 1 over 4, that the exponent is equal to what? X raised to power 1 of x multiplied by the raised to power 4, then with what? 1 over 4. Yes, you take whatever you do here, you do there. Alright, so by the time you expand this, so you have what? Let's write it here. So you have 2 raised to power 1 over 4, okay, is equal to this. We cancel this now. So you have what? X raised to power 1 over x. Yeah. So now we find a way. If you compare the integers, 2 is equals to x equals to 4, you are not right. It's not balanced. So we find a way of getting 1 over 4. What exponent can we give to 2? That when we multiply it out, you give us 1 over 4. So you can say what? Let's say 2 raised to power 4 multiplied by 1 over 4. It's not correct, because 4 times 1 over 4 will give us 1. 4 times, so let's say 16. Yes. By the time we put 16 here now, so you have 4 over 1 times 1 over 16. 4 here, 1, 4 here, 4. It will be what? It will give you 1 over 4 back. So that means 2 raised to power 1 over 4 can be expressed as what? 2 raised to power 4 multiplied by 1 over 16, the exponent. So we have what is equals to x raised to power 1 over x. Okay? Now, by the time you now looking at what you have here, you just look at it. So yeah, you have what? 2 raised to power 4 is what? 16. Raised to power what? 1 over 16 is equal to what? X raised to power 1 over x. Obviously, comparing the integers, this is 16, this is x, then 1 over 16 equals to 1 over x. So obviously, x is equals to 16. You can see that it's very simple. It toes the line of the previous one. Now let's look at another example. I want to give you enough example in this video. So let's solve one more example so that you understand everything in detail. Now let's look at another example. Let's look at another example here. Find the value of x and y in the following equation, the following exponential equation. 2 raised power x plus 2 raised power y is equals to 320. Okay? Now, how do we solve this? It's very simple. Now let's find the LCM of 320 first. So I say 2 raised power x plus 2 raised power y is equal to, this will be 32 times 10. Yes. So with this now, since 2 integers are common, so we can find the integer of 2. We can get 2 from 32. So we have 2 raised power 5. Yes. 2 raised power 5 is 32. Then multiply by what? Multiply by, this is 2 raised power 1 times 5. Yes. Because 10 is 2 times 5. So bringing this one together, because they have the same integer, you have what? 2 raised power what? 5 plus, that's 2 raised power 6. Remember, according to the law of indices, x raised power 1 times x raised power a times x raised power b. That will be x raised power a plus b. Okay? That. Then multiply by 5. Alright. So this 5, you can still do something about it. How? Okay, let's say this 2 raised power 6 now multiply by, let's say 4 plus 1. Yes? Yes. Why do we use 4 plus 1? We want to see whether we can still get an integer of 2 from 5. So the multiple of 2 will come on. You know what? 2 raised power 6 times this 4 is 2 raised power 2. Then plus, how do we express 1 in form of a power of 2? So 1 can what? 2 raised power 0. Okay? So we can have that. Yes. So with this now, let's come here. So you're going to know what? By the time you expand this, we have what? 2 raised power 6 times 2 raised power 2, okay, plus 2 raised power 6 times 2 raised power 0. Yes. So this one what? 2 raised power 6 plus 2, that's 8, plus 2 raised power 6 plus 0, that's 6. So that implies that this particular expression, so we can have what? 2 raised power x plus 2 raised power y is now equal to what? 2 raised power 8 plus 2 raised power 6. So comparing both left and right hand side of the equation, 2 raised power x equals to 2 raised power 8, 2 raised power y is equals to 2 raised power 6. So that means x is equals to 8, it means x equals to 8, and what? And y is equals to what? 6. Yes. So with this, we have come to the end of exponential equations. I believe you've been able to understand the details of how these equations could be solved mathematically. Don't forget to click on my the notification bell in my channel. Click on the notification bell so that each time I upload amazing videos like this, you'll be duly notified. And do well also to subscribe if you have not subscribed. Do well to like and comment. If you have any questions bothering you concerning exponential equations, put it in the comment section. I remain Dr. OJ. God bless you.